Now, in this episode, we will look at the problem of finding the in-order successor of a given node in a binary search tree. And let's recap what the steps are in in-order traversal of a binary search tree. Well, first we explore the left subtree. Then we explore the root. Okay, and then we explore the right subtree. Well, essentially, that means that if you have well, let's take some examples, and I think that those are kind of illustrative. Well, if we take, for instance, the node 5, the left child of 5 represents essentially the past, right? When you're traversing this tree in a breadth first search in-order traversal, well, whatever is on the left child will represent the past, because we have to traverse the left subtree before we can traverse 5. So the fact that you're at 5 means that the future, which is the successors, are only going to be on the right. Okay. Now, if right meaning that, well, the right subtree of 5 is rooted at 9, and all we have to then do essentially is traverse 9 and find essentially the smallest element in the right subtree, which is obviously going to be the leftmost element of the subtree which is rooted at the right child, which is 9, and this is going to be 8. However, what happens if there is no right subtree? So let's take an example of 13. Now in 13 there is no right subtree, and if we have arrived here, well, there is no left tree either. So if we have arrived here and there's no right subtree, it means that we have to now make a determination of whether 13 itself is a left child or a right child of its parent. If it's the left child of its parent, then obviously the successor has to be the parent itself. Now in this case, 13 is the left child of its parent, and so the in-order successor is 15. Let's take another example of, let's say, 15 itself. Okay, now 15, we've arrived at 15, and 15, after having arrived at 15, well, what's on the left of 15? Well, whatever is on the left of 15 is the past, right? Which is something we would have explored before we explored 15, because that's the steps in order traversal. So essentially, in 15 we look at 13, but we won't, because that's a past. Well, what's the future? Well, future we'll look at the right subtree, but there is no right subtree. So again, we are in the same predicament as we were in the previous example of 13, which means that now we have to make a determination of whether 13 is a left child or a right child. Well, 15 is a right child. So when 15 is a right child, we have to find the in-order successor of 15 will have to be the first parent up the chain, which basically is the parent of which has the left subtree which houses 15. So this is somewhat confusing to state, but maybe easier to understand and very intuitive if you really think about it. Now, by the way, one thing, I'm assuming that this binary search tree has parent pointers, so we can navigate back. So in this case, I'd like to navigate from 15 back to its parent 9, check whether 9 itself is a right child. It's not. So I keep navigating up back to 5 and check whether it's a right child. It's not. Keep it's a left child or not. So we start at 15 and we navigate up to 9 and check whether 15 is a left child of its parent. It's not. We navigate again from 9 to 15, check whether 9 is a left child of its parent 5. It's not. navigate to 5 and check whether 5 is a left child of its parent 38. It is. So we mark 38 as the lower common, the in-order successor of 15. Now let's say how we can write a pseudocode for this. So we discussed three kind of examples. One was the example of 5, one the example of 15, and one example of 13. And these three kind of exemplify three different cases that we need to handle in order to compute the in-order successor. So the in-order successor given node, which is the root node, now if the root dot right, in order node. Now we could have been given any random node to find the successor of, obviously. So we may not even know the root of this tree. And we check whether if the node that we've been given has a right subtree. Okay, and if the node has a right subtree, well then we navigate to the right. Node is equal to node dot right, and then while node dot left, we go left. Essentially node equal to node dot left, and once this loop is done, we will simply return node. So what are we doing here? It's pretty simple. We're simply finding the lowest element in the right subtree. Now if that is not the case, we discussed the other example of 13. Now in this case we say, well, if the node that we are looking at, of course, doesn't have the right subtree, but is it the right child of its parent? So we say whether node equal to node.parent, left child of its parent. So we say node equal to node.parent.left, and if so, then we simply return the parent as the in-order successor. Next, we consider the other example of 15 that we considered, which is else. Now in this case, we actually have a loop where we are trying to we're trying to find such a parent of this node, which is also the left parent of its parent. So node.parent is not equal to node.parent.left. Node is equal to node.parent. And we will return node.parent. So this is a pretty straightforward and simple algorithm in order to compute the in-order successor.